Good afternoon, friends. Today we will be discussing chapter number 1, number system, codes and binary arithmetic. Number system. So there are different types of numbers, that is decimal number, binary number, octal number and hexadecimal. So how we are going to represent these numbers? Decimal means a number will be having base, that is 10, and the numbers are from 0 to 9. Then binary numbers. In binary the base is 2, we are having only two numbers, that is 0 and 1. Next is your octal. Octal means 8, so the base is 8 and you will be having number from 0 to 7. And hexadecimal numbers means number from 0 to f, that is 0 1 2 3 4 5 6 7 8 9. After 9 the numbers are represented by a, b, c, d, e and f. So these are the different types of numbers, that is decimal which is having base 10, binary which is having base 2, octal having base 8 and hexadecimal number system having base 16. Now we will discuss one by one. First is your binary number system. Binary, the name itself suggests binary means we will be having only two numbers, that is 0 and 1. Okay, now we will discuss one by one what is bit, what is nibble and what is byte. Bit is the smallest unit of a data of a binary number system. It can hold only a data, that is 0 or 1. So bit will hold only a data 0 or either 1, so it is having capacity to hold only one bit. Next is your nibble. What is nibble? It is the collection of 4 bits. When 4 bits will come together, a nibble is formed. Next is your byte. It is collection of 8 bits. So in the exam they might ask you what is the definition of bit, nibble and byte. Next we will discuss how to convert binary number system into decimal number system. Okay, so there is table. From this table you can represent a binary number into decimal number. Now there is a point, so in the point we will be having two, one is your left hand side and one is your right hand side. The numbers on the left hand side are represented by the power of 2 raised to 0, 2 raised to 1, 2 raised to 2 and 2 raised to 3, and on the right hand side the numbers are 2 raised to minus 1, 2 raised to minus 2 and 2 raised to minus 3. We are well familiar, we can write 2 raised to minus 1 as 1 as to 2, 2 raised to minus 2 as 1 as to 4, 2 raised to minus 3 as 1 as to 8. Now you will be given one binary number and you have to convert that binary number into decimal. Now let us get this concept clear by a simple example. There is one binary number which is represented over here, that is 11101.1101. The number which are at the left hand side we are going to represent it by the power of 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3 and 2 raised to 4. Okay, so what is first number, binary number, that is 1. So we have to multiply 1 by 2 raised to 0. Next is your what, 0 into 2 raised to 1. Next is 1 multiplied by 2 raised to 2. Next is 1 into 2 raised to 3. Next is 1 into 2 raised to 4. Now what is 1 into 2 raised to 4? That is 16. What is 2 raised to 3? That is 8. What is 2 raised to 1? That is 0. Anything multiplied by 0 is 0. So that is 16 plus 8 plus 4 plus 0 plus 1. What is next? 1 into 2 raised to minus 1, that is 1 upon 2. 1 into 2 raised to minus 2, that is 1 upon 4. Next is 1 into 2 raised to minus 4, that is 1 upon 16. So after solving this we will get 29.8125, that is a binary number which is converted into decimal. Like this you can solve number of example. Now the number over here is 101111, that is binary number, you have to convert it into decimal number. Now there is no decimal point in this system, so what we will do, we will just write down the number and we have to multiply by this chart which is given here. By considering this chart, what you will get, the numbers which are on the left hand side, so there is no decimal point. So how will you convert this? That is 1 into 2 raised to 0, 1 into 2 raised to 1, 0 into 2 raised to 2, 1 into 2 raised to 3, 1 into 2 raised to 4, 0 into 2 raised to 5. So it is being shown over here. So anything multiplied by 0 is 0. So what is 2 raised to 6? That is 64. 2 raised to 4, that is 16. 2 raised to 3, that is 8. Anything multiplied by 0 is 0. 2 raised to 1 is 2, and 2 raised to 0 is always, anything raised to 0 is always equals to 1. Okay, so this binary number is converted into decimal number system. So this is the process by which we will convert binary number into decimal number system. Okay, so for converting binary into decimal, you should be well familiar with this particular chart. Okay, now we'll discuss second number system, that is how to convert decimal number into binary number system. Okay, so it is also called as double method. So how will you convert decimal number into binary number? It is a very simple process which I will explain by a simple example. So what is that process? So the number is divided into two parts. Again, left hand side and right hand side, the number, or which will be explained by the example which is shown here. The number or the integer is 26. So we have to convert that particular decimal number 26 into binary. So what we will do? We will first divide that particular number by 2. So by doing this calculation, when you will divide 26 by 2, you will get how much? 13. So what is the remainder in this case? 0. 13 we have got. Again we have to divide it by 2. What is that answer? 6. And what is the remainder? 1. Again we have to divide 6 by 2. So we have to continuously divide by 2 and we have to write the remainder. So this is the thing, or by using this method also we can solve this. So what is that number? 26. So divided by 2. After dividing 26 by 2, you are going to get 13. So what is the remainder in this case? 0. Again divided by 2. So that is 6. What is remainder? 1. Again divided by 3. What is the remainder? That is 0. Again 1. And whatever is the last number, so it will be coming here. You have to write as it is. Okay. So, and whenever we are going to write a particular binary number, you have to write from bottom to top. So what is that number? 11010. 11010. So we have converted decimal number into binary number. Now for fractional part. So for fractional part, what you will be doing? Suppose there is a number 0.47457. So you have to multiply it by 2. After multiplying 2, you will get 0.194. So what is the 0 is there? Okay, so you have to write here 0. Again number is 0.194 divided by 2. So what will be getting? 1.82. So write 1 over here. Next is what? 0.828. Again multiplied by 2, you will getting 1.65. Write down 1. Next 0.656 into 2, 1.312. Again write down 1. Again 0.312 into 2, 0.64. So what is that? 0 is there. Now what is the number? 01101. Now the counting, or how you are going to write? You are going to write from top to bottom. So what is that? 0 1 1 1 and 0. So that number is what? 26.047057. That is decimal number we have converted into a particular binary number. So what we have to remember here, whenever a number is given, so the number given here is what? 26.057. So 26 we have to divide it by 2, and the fractional part you have to multiply it by 2. So this is the process by which we are going to solve a particular example. So today what we have studied? We have studied two concepts, that is how to convert binary number to decimal, and second decimal number to binary. So decimal to binary is also called as double method. So these are the two methods by which we are going to convert a particular number system into another system. Okay, that's all. During next lecture, we will be discussing the following points, that is how to convert hexadecimal number into decimal number system and decimal to hexadecimal. Okay, these 2 points we will be discussing during next lecture.